migration in the Columbia River. Now, first, what are we talking about? We're talking about salmon, of course. They are a significant food source to all humans, well, I mean the humans here at least, and to the local environment along across the Pacific Ocean due to their life cycle and migrations. Now, also, let me tell you about El Niño and La Niña themselves. These are climate cycles that alter wind strength and direction and alter water temperature as well. Now, why did I just bring that up? Well, because ENSO cycles affect water temperature, I figured at the start of the study whether or not these ENSO cycles could potentially affect salmon migrations and timings. And this is going to be important because if we could study ENSO and potentially other weather patterns like it, we can then more accurately predict when salmon are going to begin their migrations across a year. Now, while Daniel and I were looking through this, he's my capstone advisor, we found a paper written by Thomas B. Quinn and Dean J. Adams who counted all data on salmon migrations in the Columbia River. Now, their data goes up all the way to 1993, so after seeing this, we changed course a little bit and decided to study, since this study concluded, how have salmon migrations changed over time. Now, a key part of this study done by Quinn and Adams is that they also recorded water stream temperature in the Columbia River and started to make a correlation between the two that we will get to later. So, the finalized research question that we came up with is that given ongoing climate warming and climate change in general, how has migration timing the Anadromous fish into the Columbia River changed? So, to study this, we searched for a good database to start with and found the Columbia Basin Data DART project called Data Access in Real Time. There it catalogs the exact numbers of fish per day and temperature across the Columbia Channel, and all the data was counted via manual fish tagging, fishing records, and fish sampling from hatcheries and dams. Once we got the data, we were able to chart it out into Excel and started making graphs and figures and doing calculations to start making correlations between this salmon data and temperature and ENSO cycles. The results is that shad migration half-rate point dates occurred significantly sooner after around the year 1975. Sockeye halfway migrations declined steadily as time progressed, and Chinook salmon were found to have very little change in their halfway points across all the study time from 1939 to 2025. Starting with Chinook salmon, as we can see, it remains relatively constant around September 2nd, and then after 1980 gains a little more variance over time as it has a sort of oscillating motion. For sockeye, starting around 1940, it stayed around January 4th, but then the date steadily became earlier to declining by about 2 weeks over the span of 8 years. And then after that, little has changed for the past 20 years. And finally, we have American shad, which has, as we can see, the most noticeable change, where from approximately July, at 1945, it had a migration halfway point at July 17th. By the way, just clarify if I forgot to mention this, we studied the halfway points of these salmon migrations, where throughout the whole year, the total amount of salmon was counted. So we decided to look at the halfway point of the total amount of salmon that were counted throughout the year to calculate a halfway point of all the salmon. Sorry if I did not mention that previously. So for the shad halfway point, it had half of the shad that migrated in a year was migrated after July 17th until 1950, where it rapidly shifted to an earlier date to around June 14th by 1985, and then it stayed relatively constant for the past 45 years. Overall, for temperature, we have noticed that there was a distinct warming from 1950 to 1980, but then there has been very little change since then. Changes in the shad halfway migration dates appear to have a sort of correlation to the increasing temperatures, so Daniel and I suspect that there may be a correlation in that shad throughout evolution and adaptation have adapted to the increasing temperatures to help to better time their migrations. As such. Now, getting back to ensocycles, don't worry, I haven't forgotten about this. I made an average of how many of years with La Nina, El Nino, or neutral weather cycles, and then made an average of the dates at which the salmon halfway migrations occurred. And I've noticed that there are noticeable trends across the salmon for each individual salmon species. However, across all the species, there is a lot of variance, with each one seemingly to have their own unique little response to ensocycles, if we could call it that, because I'm still not sure if this generally means that ensocycles do affect salmon migrations. So in general, we're going to need a lot more data to confirm all that. So to wrap it all up, all three species are migrating at earlier dates. We have counted that. Most changes in migrations occurred before 1980, so we'll need to look at, for future research, we'll have to look at if anything changed in 1980 to see if it had any effect on salmon. Also, salmon migration date is heavily correlated with warming temperatures, given what we've discussed. River temperatures and salmon halfway migration dates have not changed in the past 25 years, despite increasing overall temperatures. So if they're having maybe a different change, such as the rate at which they're coming, or overall how they're doing, we're going to have to look at that for future research. And also, finally, there appear to be, yes, some unique responses to ensocycles across species. However, we just have too little data to really cement that conclusion. That concludes my study, and I would like to thank Daniel Schindler, Jennifer Goslin for helping us find the data sets that we were requesting, and also the University of Washington and Columbia Basin Research for their resources. Thank you. Any questions? Yes?
This is maybe not a full question, but a reflection on your point about despite warming sort of like atmospheric temperature, not seeing a change in the river temperature. I'm curious if you know more about like where those data are recorded in the river, and then also just like some reflections on like what feeds the Columbia River. Like, has there been restoration efforts that you think could make a difference in temperature, or I mean, some are like fed by glaciers, I don't think that's the case of the Columbia, but I don't know. Yeah, so just, I'm curious if you have thoughts on that temperature piece.
Okay, now, I would have loved to dig into that, however, given time restraints and me juggling through assignments, we didn't have a lot of time to look into that very well to check for other potential factors that could have contributed to any differences in salmon halfway migration dates. So once again, it's another future research thing where we need to look a lot more into this to see if there is some sort of other effect going on.